Good morning, children. Today we are going to solve certain numericals based on the topic Ampere circuital law and its applications. Okay, so first numerical I will read here and then we will solve it. A solenoid of length 0.5 meter has radius 1 centimeter and is made up of 500 turns. It carries a current of 5 ampere. What is the magnitude of magnetic field inside the solenoid? Now in this case it is very important that the number of turns per unit length are important. Okay, so because we know that the formula for magnetic field B is equal to mu naught Ni, okay, where this N stands for the number of turns per unit length, okay, and the number of turns I will write down here, number of turns per unit length, small n, is equal to total number of the turns which is given here divided by along how much length this number of turns are spread out. Okay, so n upon L. Now we have 500 number of turns across 0.5 meter. Therefore, there are 1000 turns per meter. 500 by 0.5 meter. Okay. Now, length is given 0.5 meter. Okay. So, I'll write down L is equal to 0.5 meter and radius is given 1 centimeter. Now, all the units we have to convert into the SI unit. Okay, so radius is given in 1 centimeter, but we will convert it into 0.01 meter. Okay, now you can see that clearly L is larger than A or R, isn't it? Okay, so we can use the formula for the magnetic field inside a long solenoid. Okay, and that is nothing but B is equal to mu naught into Ni. Now mu naught value is 4 pi into 10 raised to minus 7 into small n, we got the value 1000 turns per unit length, okay, and multiplied by the value of the current, it is given as a 5 ampere. Okay, so if we calculate this value, it comes out to be B is equal to 6.28 into 10 raised to minus 3 Tesla. In such a numericals, it is very important to convert number of turns. If they have given the number of turns, total number of turns, then we must convert here the number of turns per unit length. And the formula you have to always keep in mind that small n is equal to capital N upon L. Okay, so by this we can get the value of B as 6.28 into 10 raised to minus 3 Tesla. Okay, now the next example we are going to consider now, that is a copper wire having resistance of 0.0 ohm per meter is used to wind a 400 turn solenoid of radius 1 centimeter and length 20 centimeter. The radius of the solenoid is 1 centimeter and length of the solenoid is 20 centimeter. Find the EMF of the battery which when connected across the solenoid would produce the magnetic field of 10 raised to minus 2 Tesla near the center of the solenoid. Because when the battery is connected to that particular solenoid, then the current will flow through the solenoid and the magnetic field is generated by the solenoid. We have to find out the amount of magnetic field which is produced, that is 10 raised to minus 2 Tesla, it is given, and how much must be the EMF of the battery. Okay, so for this we are going to consider here the length of the wire used. Okay, so very important thing is that here we have to find out first the length of the wire used. So I'll write down here length of wire used is equal to, now one turn is having the circumference is equal to 2 pi r, isn't it? That means the length of one turn is 2 pi r. okay, and multiplied by how many such a turns are there. Okay, so I'll write down here 2 pi r into number of turns. It will give us the total length of the wire used. So we have here 2 pi multiplied by r is given, isn't it, 1 into, that is 1 centimeter radius is given, so I will take it as a 1 into 10 raised to minus 2 meter multiplied by number of turns, they are 400. Okay, so I'll write down here 400. Now they have also given that resistance per unit length they have given, per unit length they have given. Okay, now it is given as 0.01 ohm per meter, or we can say meter raised to minus 1. Okay, so we have to find out the total resistance of the wire. So I'll write down here total resistance of wire R is equal to 2 pi into 1 into 10 raised to minus 2 into 400, this is the length of the wire, multiplied by the resistance per unit length of the wire, that is 0.01 ohm. So I get it here, R is equal to 8 pi, okay, 4 into 8 pi, isn't it? So 4 into 2 pi is 8 pi multiplied by, if we complete the calculations of the power, we get it here 10 raised to minus 2 ohm. Okay, now that means this is the resistance of the wire, this much amount, okay, this much length. Now again we have to find out the number of turns per unit length, because this is essential to find out the formula. Number of turns per unit length, and that is given as a small n is equal to capital N upon L. Okay, so number of turns are 400, and the length of the wire also, they have length of the solenoid they have given as a 20 centimeter. So I'll take it here 20 into 10 raised to minus 2 meter. Okay, so we get it here, n is equal to 2000 number of turns per meter of length, per meter of length. Now we will have the basic formula, isn't it? Okay, so B is equal to mu naught into Ni. But they have asked how much is the EMF of the battery. So we have to convert this formula of I, current, is equal to EMF upon R. So I'll write down here, therefore is equal to mu naught N E upon R. This is the EMF of the battery. So we will have E is equal to, that only we have to find out, BR divided by mu naught into N. Okay, so this comes out to be, B value they have given as a 10 raised to minus 2 Tesla. Resistance we have found out, that is 8 pi into 10 raised to minus 2 ohm. Okay, divided by mu naught is 4 pi into 10 raised to minus 7, and number of turns are 2000. Okay, so if we calculate this value, we can get it, E is equal to 1 volt. Okay, so you have to keep in mind the method always whenever a particular numerical is given in a different way. The most important thing is that suppose it is given a solenoid and we have to convert it into the length of the wire used, that is nothing but circumference of one particular loop multiplied by total number of turns, that will give us the total length of the wire. Okay, then we have found out resistance per unit length they have given. So total resistance of this much length wire we have found out. Again we have found out small n, number of turns per unit length, that is given by total turns divided by the length across which those turns are traced. So 400 divided by 20 into 10 raised to minus 2. So these 3 steps are important, then we will have the basic formula. Okay, thank you.